guys, today we're going to finish out the week by looking at Simpsons Rule. It is another approximation technique for functions that we can't integrate very easily, and it is similar to the trapezoidal rule. There are a couple minor differences. We are not going to take the time to derive it. I can always send that to you if you'd like, but let's just go ahead and jump in to Simpsons Rule. And again, the examples we use today are functions we already know how to integrate, and we're just using them as examples. Okay, so typically we would use this when we can't integrate any other way. Okay? So if we're trying to integrate our function, Simpson rule says that we take b minus a over 3n. Okay, so that's already different than the trapezoidal rule. One main difference is that n has to be even number of intervals, where it did not have to be that way with the trapezoidal rule. Okay, we always used one, but you don't have to. Here you do have to. Okay, now we start putting in our functions. Okay, so we start off with our first f of x, okay, and then we go to 4 times the next one, okay, and then we go to 2 times the next one, okay, and it's going to keep alternating from 4 to 2 to 4 to 2, okay, until we get to that last set of 3 terms. Okay. So we keep on going. Okay, until we get to the third from last term. Okay, so we're going 4, 2, 4, 2, 4, 2. Then we would have a 2 here. We have a 4. And then our last term is just 1. Okay. So the first and the last have a coefficient of 1. Everything in between goes 4, 2, 4, 2, 4, 2. And it should always end up being 2, then 4, then 1. Okay, and that has to do with those even number of intervals. Okay, so this is your Simpsons rule right here. Okay, we're actually going to use the same examples that we used with the trapezoidal rule. And so you can always go back and check what answers we had there. Okay. I'm also giving you the same assignment so that you can compare how these rules work. Okay, so I believe our first one the other day was sine of x. Okay. We went from 0 to pi. And this is one we do know how to integrate. We've talked about that. That's negative cosine of x. Okay, and we ended up getting 2, I believe. So let's see how close to 2 that Simpsons rule gives us. Okay, and we're first going to do it with n equals 4. Okay, so they've told us we're going to split our number line into 4 parts. So our starting one was 0, our stopping one is pi. Okay, so we cut it in half. So that's pi over 2. That gives us 2 intervals. So to get 4 intervals, we just cut in half again. So we have pi over 4 and pi over 8. Sorry. How about 3 pi over 4? Okay, so 0, pi over 4, pi over 2, which is 2 pi over 4, 3 pi over 4, and pi. So here we have our 4 intervals. Okay. Now to use Simpsons rule, this is our first one, so when we go to do this, we're going to have a coefficient of 1 and a coefficient of 1 at the end. This is what I do so that I keep straight. Okay, and then it goes 4, 2, 4. Okay, so if you'll keep your endpoints as 1s and then do the alternating pattern 4, 2, 4, you'll be okay. Okay, so let's go ahead and see what we get as an approximation. Okay, so we take b minus a, so in that case it'll be pi minus 0 over 3, and then we look for n, which was 4. Okay, and again they give that to you. And the more intervals you have, the closer you'll get to your answer. Okay. Now these f of x's just mean we plug in our number into our original function. Okay, so I'm going to take 1 times the sine of 0 plus, now I need to go to 4 times the sine of pi over 4, okay, plus 2 times the sine of pi over 2 plus 4 times the sine of 3 pi over 4. And then finally 1 times the sine of pi. Okay. So now you can put this all in your calculator right now. That's perfectly fine. I'm going to simplify it a little bit just to make it look nicer. So this is pi over 12. Sine of 0 goes to 0. Okay. Again, using our charts, sine of pi over 4 is root 2 over 2. Okay. Sine of 90 degrees or pi over 2 is 1. Okay. And then 3 pi over 4, the sine of it is also root 2 over 2. Okay. And then the sine of pi is 0. Now, right now I can put it together a little bit more if I wanted to, or go ahead and go straight to your calculator. That's up to you. Okay, 0, 2, and 0, so I have 2 plus. And then here I have 4 over 2, so that's 2. Root 2, and I have 2 root 2 here as well. So it looks like this is what I have. If I'll go ahead and put that in my calculator, make sure if you we're doing it up above with sine that you are in radians. Okay. So okay, I'm videoing right now, okay? And we get 2.005. Bye. Okay, so we do know our answer should have been about 2, so looks like we did it about right. Okay, so now let's try it, but try it with 8 and see if we get any closer. Okay, although I would say 2.005 is close enough, okay, most of the time for anything. Okay. So if we're going from 0 to pi again, we have pi over 2, okay, and we have pi over 4 and 3 pi over 4, and then we just again have to split those in half. So this is pi over 8, 2 pi over 8, we already have marked. This is 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, and then 8 pi over 8, which is pi. Okay, so that's how we split it up. Now using Simpsons rule, let's go put our coefficients, or at least think about them. Okay, so we know that the beginning and the end are 1s. Okay, and then it alternates between 4, 2, 4, 2, 4, 2, and you always end up with the 4 before the 1. Okay, so that's how we know what coefficients to use for Simpsons rule. Okay, so let's go ahead and see what we can get. Okay. So we have pi over minus 0, b minus a, times over 3 times the intervals, so 3 times 8. Okay, we have 1 times the sine of 0 plus 4 times the sine of pi over 8 plus 2 times the sine of pi over 4 plus 4 times the sine of 3 pi over 8 plus 2 times the sine of pi over 2 plus 4 times the sine of 5 pi over 8 plus 2 times the sine of 3 pi over 4 plus 4 times the sine of 7 pi over 8 plus 1 times the sine of pi. Okay. Now, I would probably just put this all in my calculator, okay, because again, pi over 8 are ones that we don't know without using that half angle rule. Okay, so let's go ahead and put it in our calculator. I do know that this is pi over 24. I also know this is 0 and that's 0. So 4 times the sine of pi over 8. Okay, and just start plugging it in. Again, you do have to be in radians to do it this way. Of 3 pi over 8. We're going to hope I have the right amount of parentheses in here. Okay, so I added those all up. I'm going to multiply by pi and then divide by 24. Okay, and I end up with 2.0003. So here, to get a digit that's not 0, I do have to go to the 10,000ths place. So it is closer than the 2.005. Okay, but feel fairly confident then. If we were doing this without knowing what the integral of sine x was from 0 to pi, it sounds like it would be pretty confident to say 2. Okay, so hopefully that demonstrates the rule. Okay, let's do 2 others real quick. Again, the same ones that we did with the trapezoid rule. Okay, so let's look at from 0 to 2 of x cubed dx, where n is 4. Again, this is one that we would want to integrate just normally, okay, because it is just the simple power rule, but just to demonstrate how this rule works, okay. We do know that this should be 4, okay, from the previous work, okay. So we do want to split it from 0 to 2 at 1, at a half, and at 3 halves. Okay, so that gives us our 4 intervals. This is a coefficient of 1 and 1, 4, 2, 4. Okay, so that's the big part of Simpsons rule, is getting those coefficients right. Okay, so b minus a, so 2 minus 0 over 3 times the number of intervals, which is 4. Times, now we just start plugging in, 1 times 0 cubed, plus 4 times 1/2 cubed, plus 2 times 1 cubed, plus 4 times 3/2 cubed, plus, we're at the end, so it's a coefficient of 1, 1 times 2 cubed. Okay. So again, you can plug that all in your calculator. I'm going to simplify before I do it, but 2 over 12 is 1/6. Okay. So 0 cubed is 0. Okay. A half cubed is 1/8. So I get 4/8, which is 1/2. Okay, so here I have 0. This is 1/2. Okay, 1 cubed is 1. 1 times 2 is 2. Okay. 3 cubed is 27. 2 cubed is 8. So I have 27/8, okay, times 4. So that would be just 27 halves. And then 2 cubed is 8 plus, or times 1 is 8. Okay. So we could even do more simplification here or put it in your calculator. A half plus 27 halves would be 28 halves, which is 14. This would make 16. This would make 8, or 8 plus 16 is 24. So 24 times a sixth is 4. Okay, so which actually ends up being what the answer actually is. Okay, so sometimes we do have functions that make it really nice and we get exactly what we would have. Okay, so, and then finally, the last one we did as an example on Monday was from 1 to 3 of 4 minus x squared. Okay. And again, let's do n equals 4. Okay, oops. So from 1 to 3, cut it in half at 2, cut it in half at 1 1/2, and then 2 1/2. Or this is 3 halves and 7. Just kidding, 5 halves. Okay. So we need a 1, a 1, a 4, 2, 4. Okay. So b minus a over 3 times how many intervals there are. And again, you will be given the intervals, how much you're supposed to do. So we do 1 times 4 minus 1 squared plus 4 times 4 minus 3 halves squared plus 2 times 4 minus 2 squared plus 4 times 4 minus 5 halves squared plus 1 times 4 minus 3 squared. See if I can move that a little bit. Okay, so this is 2/12 or 1/6 again. And I'm not going to simplify too much. I'm going to plug it in my calculator in just a second. So 4 minus 1 is 3. So we have 3 here. We have, I'm not going to worry about that one, except that's 4 minus 9/4. Plus, and then 4 minus 4 is 0. 0 times 2 is 0, so I don't have to worry about that one. This is 4 times 4 minus 25/4. And then 4 minus 3 squared would be -5. Okay, so now I'm going to go to my calculator and plug in all of this, and then I just divide by 6 at the end is how I handle that, but you do it however works. Okay. And here we actually get -2/3, which is the actual answer as well. Okay, so that's Simpsons rules. Please let me know if you have any questions after watching this video. Tomorrow you're going to be doing the same 4 problems that we did earlier. Okay, but again, hope you have a great day. Talk to you later.